So guys, welcome. Thank you for joining this webinar brought to you by ABB Power Grids. We're going to be looking at data centers and whether microgrids can play a part in the future of the data center and the future of the power network globally. It's actually part of a series of webinars that we're arranging, and there's actually two sessions today. This is the European-based session, and there's a session later today as the US wake up, and our colleagues from the States will present a similar set of slides to that part of the globe. If you want any details of these, we can send them out to you, and you'll get registration details for the upcoming events, digital data center operations, and rethink your service strategy. So presenting today, we'll have Dario, my colleague from Switzerland. He's the Global Marketing Sales Manager for GRT Solutions for our ABB Power Grids business. And myself, Lyonette, I'm the Industry Network Lead for Grid Automation, responsible for all our automation technologies and portfolio across Europe, specifically focused on data centers as well as some other emerging and major end clients and industries for ABB. So maybe Edward will join, but if not, I'm going to start the presentation here, and I'd like to say hello to everyone on the call and welcome to this Grid Edge Technology webinar. I'd like to start the session with a safety moment, and I guess usually we would all be attending this kind of webinar from our place of work, and so we would be observing safety procedures in place in those locations. However, I guess today, because of the COVID-19 situation and continued lockdown in many countries, most of us today are dialing in from our homes, either from the living room, kitchen, bedroom, or home office. On that basis, we should all just take a moment to ensure that our surrounding environment is safe, but also ergonomically set up to enable us to listen and to actively participate in this webinar for the next 40 minutes. There's also a note on the slide about driving. I don't expect anyone is driving based on the current lockdown. However, if you are, could I ask that you please end the webinar here, and we will ensure that you get a copy of the recording, assuming that I am recording it. Also, just a reminder, yeah, we will try and record this and make sure it's sent to everyone. So again, apologies for some technical difficulties at the start, but I'd like to spend a few minutes just looking at some of the global trends we see over the coming 10, 20 plus years that are shaping the power sector and influencing the behavior of the players in the market today. As we know from our position today, the world is a very different place from what it was at the start of 2020. However, as we come out of this situation, it is expected that these trends would continue back on a similar path. So looking ahead, 20 years plus, it's predicted as a globe we will be consuming an additional 50% of energy, and that 50% of that power consumption will be sourced from wind and solar. With the continued rise of big data, the Internet of Things, much more use of digital technology, social media and video streaming, and recognizing our situation today and the need to be better connected virtually, all of these elements contribute to the continued growth in energy consumed by data center and information and communication technologies. It's estimated that globally we have over 40 billion connected devices today, and this will grow exponentially to around 500 billion by 2050. Each of these devices consumes and/or produces data, and therefore each has an impact and burden on the data center and ICT power infrastructure. Not directly related to data centers, however, a significant emerging market that will have a huge impact on the future power network is the rise of electric vehicles. We are already seeing a rapid growth in electric vehicles today, with approximately 15 million EV vehicles in place around the globe. The prediction is that by 2050, this will go up to around 250 million. The challenge here is to ensure we have a power network today that's dynamic and flexible enough to address the challenges and deliver the outputs of tomorrow. As the power system evolves, we need to maintain security and continuity of supply to critical national infrastructures such as data centers, and we need to do this in a sustainable way that doesn't overheat the planet, that also doesn't forget those in need of power security or compromise those living in increasingly urbanized and densely populated centers. It's now globally recognized by leading countries, industries and corporations that we need to ensure we are not over polluting the planet. We've already seen the temperature grow by about 1% since pre-industrial times, and if left unchecked, the impact on people and ecosystems will become exponential. So we need to slow down global warming, and leading companies like Microsoft, Google, Facebook and Amazon all have this at the top of their agenda. Looking at some of the current trends over the last 12-24 months and taking the current situation out of the equation for now, we continue to see energy demand grow worldwide, last year growing by 2.3%, the fastest pace in the last 10 years. The demand for all fuels increased and fossil fuels met the majority of the new demand, so we're still heavily reliant on fossil fuels, and as a result of this, the global energy related CO2 emissions rose by around 1.7%. However, because of the continued deployment of new renewables, the good news is carbon intensity of the power sector continues to fall, and we've seen a 25% reduction over the last 10 years due to the introduction of large-scale renewables, which now account for almost 45% of the world's electricity generation growth, that is, and accounts for around 25% of the global output. So we're going to continue to see energy demand grow, and we're going to continue to see more and more renewable generation introduced to meet that demand. But what does this mean for the power system? Well, in the past, the system was very linear, with generation at the top and load at the bottom, with very little going on in the middle. The network today is already much more interconnected and bidirectional, with the introduction of renewables at distribution voltages, meaning that the point of generation is much closer to the point of consumption. And for the power system of tomorrow, the complexity escalates even further. With the increased utilization of interconnectors, distributed energy resources, and microgrids adopting machine learning, data analytics and advanced network automation in order to maintain the power system's stability, security and continuity of supply. The drive towards renewables is very much from a demand side, with some of the global tech giants leading the way in this and striking up large power purchase agreements for renewable electricity to support their green agendas. Here we see the figures for last year, where Google secured 2.7 gigawatts of renewable capacity, which we will see double in 2020, with Facebook and other major players on a similar trajectory. Google has been purchasing 100% renewable energy for the past 3 years now, with the end goal of having its data centers 100% carbon free. Facebook states that they are committed to reducing their greenhouse gas footprint by 75% and reaching 100% renewable energy within this year. Amazon has committed to meet the Paris Agreement 10 years early and be operationally net zero by 2040. And we see Microsoft has committed to be carbon negative by 2030, and by 2050 they will have reversed out all the carbon the company has put into the globe since it was founded in 1975. So there's a compelling environmental case for the increased and continued drive for renewable generation. However, the good news is that the economics also start to stack up. If you look at the price point for the deployment of utility scale solar and onshore wind, both technologies have dramatically fallen in price over the last few years and are projected to continue on this track as production technologies improve and deployment efficiencies increase. Similarly, with battery energy storage, the price point for lithium ion has dropped dramatically since 2010, and it's now at a viable price point and is predicted to continue along that track. So, in essence, our power system of the future shouldn't cost the Earth either environmentally or financially, and renewable technologies seem to fit the bill pretty well. One challenge we do have when integrating renewable generation is to manage the complexity in the network. How do we ensure secure and reliable power on a dull and still day? How do we ensure we don't have overcapacity on an extremely sunny and windy day? What do we do overnight? Compared to the manufacturing industry and other large power consumers, data centers have a fairly continuous load demand regardless of the time of day or year. All these challenges bring potential instability to the power network and potential loss of supply to the end user. This needs to be dynamically managed and controlled at a grid scale, also at a distribution scale and at a local level where the end user, in this case a data center, becomes an active node at the grid edge that can manage and operate their own on-site power ecosystem and be able to ensure their own quality and continuity of supply, but may also be able to participate in the energy market as a point of generation at times when its on-site load and power demand allows. This is where grid edge technologies such as microgrids and high energy infrastructures such as data centers can potentially play an active part in the future power network. And it's at this point that we'll pass you over to Dario, our ABB Global Marketing and Sales Manager for our Grid Edge Solutions, who will talk in a bit more detail about the technology and its application around critical infrastructure and data centers.
Thank you, Danny. Hello, everybody. So I will go more in detail now on how Grid Edge Solution can support data centers. So I need to, Danny. Great, thanks. So here you see we are living in a new energy ecosystem. We currently see a big shift in the electrical value chain. We expect renewable power generation to reach more than 40% of the total capacity by 2035. And this will imply a greater volatility and so less power generation predictability. And this means that transmission and distribution system operators will be much more challenged to provide a stable and reliable power to consumer and also to data center. At the same time, we see that the complexity of the power grids is increasing, and there is the need of advanced control capabilities and digital solutions. And here we see a tremendous growth of distributed energy resources requiring control and optimization at local level so that we can extract the maximum value of those distributed energy resources and better support our customer and the grid stability as well. So today we see a transition phase from the traditional vertical power generation setup with central power generation to a bidirectional energy power flow with distributed power generation where consumers are becoming prosumers. And this is happening due to the technological innovation, the distributed energy resources cost reduction, and as well policies enabling new business models. So in the future, with digitalization, we do expect our EMesh grid even more connected, utilizing grid edge solutions and data to extract more value for our customers, but also, and more important, really to ensure the power grid stability. And we believe grid edge solutions and microgrids will play a big role in the power grids of the future. So let's clarify, first of all, what is a microgrid? A microgrid refers to distributed energy resources and loads that can connect to the main power grid or operate in an island mode. With Grid Solutions, microgrid can be operated in a controlled and coordinated way and can seamless transition from grid support mode to be completely off-grid with backup power, securing continuous operation for critical loads. Microgrids are increasingly being equipped with Grid Solutions, which are on-site connected devices such as on-site power generation, both renewable and conventional power generation, energy storage systems, advanced control, and automation. They also can include flexible loads such as electrical vehicle chargers and can integrate with building management system and data center infrastructure management system to manage the cooling system or any other variable loads. Grid edge solutions can be deployed actually quickly and easily and provides demand response capabilities, energy optimization, monitoring and reporting, and can operate and aggregate sites into virtual power plants to participate in the energy markets. So let's have a look now why grid edge solutions for data centers. With Grid Edge Solution, we enable our customer to lower CO2 emissions beyond carbon neutral and increasing data center sustainability. And we can do that by increasing on-site and remote renewable power integration, reducing operation of backup power generators. And we can enable our customer to increase operability, reliability, and resilience by decreasing dependency on utilities power and increasing data center uptime. We can enable our customer to stabilize their electrical grid by improving the power quality and gain new ability to run data center or renewable. We can enable our customer to reduce overall energy cost and increase revenues by optimizing energy resources management and enabling energy market participation. And we believe, those are great values required for data centers of the future. Let's have a look now in more detail on how we can implement grid edge solutions within data centers. The smart data center need to be equipped with on-site renewable power generation, typically from solar on the roof or nearby, and or with wind power generation. Then there is a point of common coupling of the smart data center, which is typically at medium voltage level and is located at site or very near. A microgrid or a smart data center will be equipped with grid edge solutions such as battery energy storage system, advanced real-time control, and energy management system, and will be connected to the main grid through a point of common coupling. Now, with the real-time advanced control, we are able to control the data center import or export of electricity according to the commercial or technical conditions. And with the real-time control and the energy management system, we are managing the data center power production and as well the load demand with a day-ahead forecast. And these allow us to know in advance how each asset is going to operate in the next 24 hours. With power generation forecasting and artificial intelligence, we are able to optimize the energy requirement of the data center and act in real time to store energy in advance if required, or use the energy in case of any power shortage. This will make sure that backup diesel power generator would never be switched on. In remote renewable power generation, we can also include battery energy storage for grid code compliance and for participation in the ancillary service market, for instance. And with our monitoring and control system, we can provide the full visibility of the asset performance, the overall renewable power generation contribution, and information about the CO2 emission reduction that we have done. And as well, we can provide this for the overall data center assets, so provide the full visibility. So let's have a look to the value stack of grid edge solutions for data centers. So we all agree that renewables are the future of our energy supply. However, as you add more renewable to the grid edge solutions become increasingly necessary to ensure getting the maximum value out of it. Grid edge solutions prevent the need to curtail renewable energy that could otherwise serve the data center or any other customer. So also many renewable sources, including the wind, the solar, even the hydro, require support from grid edge solutions, especially when there are issues with the utility network. And if there are problems with a data center utility power supply, grid edge solution can take this value further, enabling the data center to use the renewable energy to reduce the fuel usage when power backup is necessary. And this reduces the cost and environmental damage from the fuels that are used for backup power generation. In case of grid outages, in addition to reducing fuel requirement by up to 50%, grid edge solutions enable operational flexibility and ability to ride through longer outages, even if there is the difficulty with the fuel supply for the data center. Grid edge solutions do not only reduce fuel usage, but also reduce the need to operate additional backup power generators because it provides as well spinning reserve. Additionally, the battery energy storage in a grid edge solution also provides a new storage asset, providing further direct backup support to the existing UPS and backup generation. And together, this increases the reliability and resilience and drive the data centers towards its ultimate goal, which is the achievement of having 100% uptime. So, if you want to power your data center directly on renewables, you will need grid edge solutions. When there are issues with the utility power supply, most solar and wind projects cease to operate. The challenge lies in how they are connected to the grid, often through a grid-following inverter. And grid edge solutions solve this problem. ABB grid edge solutions include an advanced high-power grid-forming inverter that enable renewable to continue to provide energy for data centers operation. And at the same time, this advanced technology coupled with smart automation and digital control improve the power delivered to the data centers. Grid edge solutions enable the smart data center to participate in both energy and ancillary service market, and this provide a new revenue stream to help cover the cost of the initial investment. This is not just a revenue stream, this is also enable the data center operators to support the overall grid, providing services for the grid to transition to the renewable-based load generation. And we believe that this enables smart data center to increase revenues while being sustainable as well. That's the whole point here. So let's have a look now on the capability and the application that grid edge solutions can provide in a smart data centers. First of all, if we look at the resiliency, islanding, and power quality applications, we can see that with the advanced energy management system using artificial intelligence and battery energy storage, we can stabilize the power supply. We can predict in advance the local renewable power generation and as well the load demand. In case the prediction of renewable power generation for the next day is low because of weather conditions, then with our ABB eMesh solution, we can manage the data center energy by charging the battery in advance at a level which will make sure that during the grid connection outages, the smart data center will have a seamless transfer to an island operation. The battery energy storage can take over and will avoid the switch on of diesel backup power generators. And the system will keep full operation without any downtime. Other applications are the peak shaving and load shifting. With the energy management system, we are able to shave any cooling or any system power peak by providing the required energy from the battery. In this case, then we can avoid more costly power peak. And by being able to shift the load, we can also participate to the demand response market. Peak shaving with batteries become even more valuable with local power renewable generation because they complement each other. With the batteries and the smart control, on-site renewable power generation can be more independent, and data center can use their own produced power to reduce energy bills. And this is a self-consumption application that we support as well. With ABB Grid Edge Solution, it is possible to participate into the intraday and day-ahead energy and ancillary markets by knowing when the smart data centers will have an energy surplus, and therefore the data center manager could decide to sell the energy or not, depending on the situation. It can basically decide what to do. Let's have a look now more in detail about the energy management system. For a data center energy manager or operation and maintenance manager, it is very important to know how the assets are operating and whether they are planned to operate. And this they need to know in advance. So in the next 24 hours, we are able to provide information whether the assets are going to operate or not. And therefore, it is possible to plan a maintenance and basically we can plan how the equipment will operate the next 24 hours. With eMesh solutions, it is possible to have the full visibility of the daily energy management optimization cost saving, the renewable power generation contribution as well. We can see the CO2 emission savings and all asset operation setting points for the next 24 hours. It is also provide an offline digital twin, providing the data center energy manager to run energy scenarios for energy trading or plant event simulations. And this will give the full flexibility of data center owners to better manage the energy demand of a data center. So with ABB cloud-based eMesh monitor system, we can provide to data center owner the full visibility of multiple data centers with on-site detailed information and aggregated overall power generation capacity, as well aggregated load demand and any detailed asset information. The remote control monitor provide anytime and from anywhere the full overall data center information, allowing to ensure continuous operation, predict failure in advance, maximizing power performance, and take faster decisions. Through our advanced APIs interfaces, we can integrate with existing building management system and data center integration management system at data centers. ABB Grid Edge Solutions are technology agnostic and can be adopted in any data center. So in ABB Power Grids, we have an extensive experience in grid edge solutions. So our global footprint covers more than 500 megawatt of battery energy storage system and more than 200 references. We are a pioneer in energy management and optimization, and we are leading energy innovation and transition. Our goal is to support our customers to increase profitability and unlock new revenue streams, maximizing renewable integration, lowering CO2 emissions, and improving the overall power grid reliability. So this is basically our value proposition for for data centers. And now we can start really the discussion together with Danny, of any question you may have in this topic. Thank you for your attention.
Thanks, Dario. Very good. And again, to the guys on the call, apologies for the rocky start, but appreciate your time, Dario, to put that together and to explain some of the technologies that ABB has today and some of the thought leadership piece that might help drive the way we implement the next generation of technology to support data centers and to support the power network as it evolves and changes to meet the needs of tomorrow. We've had a few questions come in. I'll start with a couple. There's a question here. If we would like to implement grid edge solutions, how would we do that? So I guess this is from a data center integrator point of view. How would we go about doing that? What would be the steps for us to embrace grid edge technology on site?
Yeah, thank you, Danny. So yes, what we would do, first of all, we would sit together with the, let's say, data center owner or this customer, and we will discuss what is, what do we want to achieve. And with that, we are going to basically provide, with our advisory team, a study and really providing information on how, adding renewable power generation, adding battery energy storage, we can provide value to that data center. And then, of course, we are going to together check what is the load profile, look at the technical data, and then basically by having that, the customer can immediately see what are the benefits, right? Then when we provide this, if there is then the investment to be done, we can easily, from our side, bring the technology to support the data center in this case.
Very good. There's a question in the chat actually. How are your solutions different to your competitors? And I guess in reality, we're not going to go into a deep dive on competitor technology. I think one of the differentiators we have as ABB is the end-to-end solution. We've been doing automation and grid edge solutions for many years, and we come very much from the transmission side of the network rather than the low voltage side. And we bring the end-to-end solution, as Dario mentioned there. We start from an early engagement and a consultation point of view rather than reacting to a predefined specification. If we can work with the operators, if we can work with the integrators of data centers, so we better understand the physical infrastructure we're dealing with, the resilience of the existing grid connection, the capability that we could bring from a grid edge point of view, and we balance that all together. And also then when we deploy this kind of technology, we're able to integrate our asset performance management software that then monitors and tracks and optimizes operations. I think that's really our differentiation, that we're much more of a solution, or we see ourselves working closely as a partner with our clients and our customers to deliver an end-to-end solution from the ground up. I think if we're just responding to a specification that's predefined, and we haven't had the opportunity to help shape that, then I think you lose some of that value at that point.
Yeah, I can actually confirm that, if I may add something. So there are some companies which they bring, let's say, a software solution. There are other companies which they bring maybe some hardware. And, our strength is really, as you mentioned, the end-to-end, solution, providing the fully vertically integrated ecosystem, getting the data from the field, from the devices, and then bringing back to the customer with valuable, information, and using data to provide more value to our customer is, I believe, our strengths in how we can support our customers.
So there's another one here. I operate a data center, and we get most of our renewables through PPAs off sites. how would grid edge solutions work in that situation? So you know the scenario. I mentioned it in my slide. Large tech giants strike deals directly with the offshore wind farm generators, bypass the commodity market effectively. How would grid edge add any value in that scenario? Dario, maybe you could take
Yeah,
that one.
yeah, Danny, thanks. So basically here we have plenty of experience and we have provided with that solutions in many of those applications. Basically, we see that, previously there was not so strict grid codes requirements. And now we see that by adding plenty of renewable in the power grids, because of, the size of it, this can be destabilizing the network. So by bringing grid edge solutions with energy storage system, we can really, first of all, be grid code compliant, meaning that we will avoid, curtailment. So basically, we are really sure that the power that we are getting come from renewable power generation, and we ensure as well that the investor on this, renewable power plant will get the maximum out of it because basically we avoid curtailment of these power plants, and as well with we can as well provide more value by, provide, for instance, frequency regulation, or voltage support to that plant. So enabling the customer, the investor, to get a new revenue stream by getting extra revenue from the ancillary service market.
Yeah, very good. I think it's similar to. There's a question from the chat here as well. It says a lot of times the utilities don't want us to send power back to the grid. Have you done anything like this in New South Wales, Australia? Have you had any issues with energy export or frequency regulation? I think from my experience across Europe, it is very much dependent on the individual utilities. However, most utilities, in my experience across Europe, encourage participation in the market. And if you can be a prosumer and not just a consumer of energy, and actively support that grid at times where they need support from a frequency point of view, or if they need additional load, or if they need you to take yourself off grid, I think generally that is becoming more and more standard practice. And it's a tricky one because data centers are, that fundamentally you need to keep the data center operational, and that is the mode of operation. That's number one, critical. Everything else is ancillary and secondary. However, if you can implement grid edge solutions that allow you to do something to earn revenue off those ancillary and secondary requirements, like participation in the market, then it helps with the overall ecological case or environmental case, but also helps from a revenue point of view as well. We saw a case in the UK. When was it? It's a few months back, just before lockdown, Data Center World. But on that day, I think we'd had a wind farm that tripped out, and there was a couple of challenges that had kind of pancaked themselves, which meant the grid really needed participation and needed people to actually generate onto the grid. And the price point for energy at that point, typically in the UK, it's maybe 14.3 pence per kilowatt hour. It went up to 2,000 pence per kilowatt hour. So if you were able to put, maybe if you had spare battery capacity, you were able to put half an hour's worth of 50 megawatts or whatever it might be, because you've got oversized UPS. That for every half an hour, that's making £50,000. Again, compared to data centers, it's maybe small change, but the reality is, if you can do that in a managed way, it pays for itself as a self-sustaining investment, and ultimately it helps with the green case as well for data centers. And we've seen from the slides that this is an important part of the future of data center operators. They see the need to be green and to be environmentally friendly. Dario, I don't know if you've got anything to add to that one.
No, I think that you covered it pretty well, yeah, extensively.
Very good. Listen, we're getting very close to the end of the session. I think we've probably just got time for one more, and it's as the use of renewables expands in the electricity grid, how will data centers need to adapt to continue achieving their environmental and renewable usage goals? So I guess again that may be I maybe touched on that already with what I was saying about the adoption of grid edge technologies, but also what we see in the grid today, the point of generation can be quite green because it's wind and solar, but then the network itself, we're working hard with the transmission and distribution networks to ensure that the full power chain from the point of generation to the data center is environmentally friendly and conscious. So we're deploying digital substation technologies at transmission and distribution now, which mean that the physical footprint of the substation is smaller, the greenhouse gas emissions is reduced because we use eco-friendly gas insulated switchgear. Digital substation techniques mean that your voltage transformer and your current transformer are physically reduced, and again CO2 emissions are reduced. So we're trying to build a power ecosystem from generation to the data center that meets that end-to-end renewable and environmental challenge. But again, I think on site adoption of digital substation technology, embedding some form of grid edge technology, battery energy storage on site to make the data center infrastructure more self-sustainable, and also adopting some of the modern substation technologies that will actually pay dividends to the data center because the physical footprint of the substation will be reduced, which means that the data hall effectively could be increased, which means more servers per for the inside fence land take of the data center. So hopefully, well, we certainly haven't covered all the questions in the chat, and appreciate everyone's contribution. We'll go through these and hopefully come back to everyone, and also you'll get a copy of the recording. Again, apologies we haven't been able to cover all questions, but hopefully the session has been of some use to you guys. Please reach out via LinkedIn. I think you could find Dario and myself on LinkedIn, so be happy to continue the chat or continue the debate and the discussion there. Other than that, on behalf of ABB, we thank everyone for joining the session today. We apologise for the rocky start, but we hope it's been of some interest and some use. Thanks for your time. We'll close the webinar there. Thank you.
Thank you, everybody.
Thanks, Dario.